Good afternoon to those in Finland. Good morning to those joining us from Brazil. I am Lilian Pinho. I'm the head of the Science, Technology and Innovation sector here in the Embassy of Brazil in Helsinki, Finland. Today we are starting a series of webinars focusing on low carbon hydrogen initiatives in Brazil and Finland. This event is promoted by the Science, Technology and Innovation sector of the Embassy of Brazil in Helsinki as part of the Brazilian Innovation Diplomacy Program, supported by the Science and Technology Department of the Brazilian Ministry of External Relations. This first H2 Horizons Brazil-Finland webinar will explore bilateral collaboration opportunities in academic research in low-carbon hydrogen between Brazil and Finland. Brazil has a combination of among the most competitive countries in the global hydrogen market, diverse and abundant energy resources, institutional and political stability, and investment capacity in technological development. In 2023, a triennial plan was established in the context of the 2021 Brazilian National Hydrogen Policy, which set 65 actions aiming at achieving three main priorities between 2023 and 25. Define a regulatory legal framework, boost investments in research and development with a focus on cost reduction, and increase access to financing. Among the deliverables, we can highlight the Green Hydrogen Legal Framework, which was approved and sanctioned in August of 2024, creating a legal foundation for green hydrogen and enabling resources for infrastructure investments, reinforcement of research and development actions, and building of low-carbon hydrogen production plants in all 5 regions of Brazil. Looking at the future, plans are to consolidate Brazil as the country with the lowest production cost of low-carbon hydrogen by 2030, with a special focus on hydrogen obtained from water electrolysis, which is still not competitive compared to other hydrogen production technologies. Moreover, to establish until 2035 low-carbon hydrogen hubs in Brazil, integrating the whole chain from production to storage and transportation. Brazil has the technical potential for hydrogen production estimated at 1.8 gigatons per year, including exploitation from energy resources that still require technological developments to reach commercial scale. In these particular aspects, the academic research plays a crucial role and can be a potential field for collaboration between Brazil and other partner countries, such as Finland. So today, we are going to have the opportunity to learn from government and academic representatives of both Finland and Brazil about the hydrogen outlook, its policies, developments, and applications, as well as have access to some of the most relevant academic research and initiatives in the topic. This webinar will be divided in 2 parts. Right now, we have here with us the participants of the second part. So I think we will invert the order. And we will have then the 2 parts, and we'll have a brief period for Q&A. So if you have questions, you can write them on the web chat, and then we will try to answer them according to the time that we have available. So right now, we will start, as I told you, by the second part, the academic representatives from Finland and Brazil. And our first presenter for this part will be João Cordeiro. So João is a physicist and researcher at the Institute for Technological Research of the state of São Paulo. He has led key initiatives in electrical engineering. Oh, wait, Osório Coelho has just come. So yeah, we welcome Osório. So I think we can start in the original order. So I think it's better that we follow the outline as much as possible. So let's go with Osório Coelho. Are you ready, Osório? Can I introduce you here? Okay, so I'm just going to introduce you and then I'll give you the word, okay? Osório Coelho currently holds the position of Director of the Department of Innovation Programs and Deputy Secretary for Technological Development and Innovation at the Brazilian Ministry of Science, Technology and Innovation. He previously held leading positions at the Ministry of Science, Technology, Innovation and Communication, at the Civil Cabinet of the Presidency of the Republic, and most recently as technical advisor to the Science and Technology Working Group during the Brazilian government transition. He will present the MCTI, the Ministry of Science, Technology and Innovation's integrated approach on hydrogen and innovation policy in Brazil. So thank you for being with us, Osório. Please, the floor is yours.
Thank you so much. Can you hear me well?
Yes, we can.
Yes, thank you. Thank you for having me here. It's an honor to be here presenting the policies of Brazil regarding the hydrogen. So I will share my screen. Just a moment. I have some trouble here.
Okay, so it seems Osório is having some technical difficulties. And we also think Mr. Timorito Numi is having some difficulty. So we can move on for now to the second part. We'll go back to the academic perspectives. And then if they manage to come in, we can proceed with the part for the governmental representatives. So, okay, we will go then to the part dedicated to academic research and initiatives and take a look at the potential collaboration on clean hydrogen between Finland and Brazil. So we will have the opportunity to learn from representatives both from Brazilian and Finnish academic institutions. And we will start with João Cordeiro from the Institute for Technological Research of the state of São Paulo. He has led key initiatives in electrical engineering, focusing on instrumentation, signal processing, and structural health monitoring. Former head of the Mechanical Equipment and Structures Lab, he now serves as director of the Energy Unit, where he is actively involved in Brazil's energy transition, hydrogen technologies, and renewable energy development. So we are looking forward to hearing your insights. João, you have the floor. Thank you.
Thank you. Thank you, Lilian. For me and for IPT, it's an honor to be with you here at this opportunity to say something about our initiatives regarding to hydrogen. So let's start the presentation here. Yeah. A brief introduction of IPT. Okay, IPT, as Lilian told us, IPT stands for Institute for Technological Research at São Paulo, Brazil. And the idea is the IPT provides technical solutions for industry, governments, and society. Okay, it's very important here in Brazil, this frame. We have some incomes from São Paulo state government, but I would like to emphasize that IPT has 126 years, so it's one of the oldest institutes in Brazil. We have more than 1,000 employees. We have a big revenue from innovation or with innovation. Every year, we have more than 16,000 technical documents issued by us. And it's important to say more 2,000 testing and analysis procedures in the portfolio. So we are very close to the industry. We have 8 units here: bio-nano manufacturing, cities, energy. I'm director of the energy unit. Technological education, building and housing, advanced materials, digital technologies, and metrological technologies. It's important to say all these units stay at the same place here in São Paulo. We have also open innovation initiative also, and we have at IPT, this is the map of IPT. So we have 67 buildings, so it's a very big area. And here we have Google, 400 people from Google, a kind of college here. Vale is a very important company here in Brazil, WEG, and a lot of companies that stay with us here physically at IPT. So making connections, making bridges between all those units and these companies together. Speaking about energy, we have 4 laboratories: bioenergy, end uses, infrastructure, and the new one, hydrogen, Lab 82. We are more than 9 people, actually more than 100 people, okay? From mechanical engineering, electronics engineering, physicists, chemistry, a lot of different fields of science. So the technological axis, we work with fuels, the idea of waste to energy, or the concept of waste to energy, agribusiness, oil and gas, mobility, and lighting. So all these are photos from our laboratories or our services doing. Specifically thinking on hydrogen program at IPT. So we have 2 big initiatives, okay? CENF stands for Center for Future Energies, okay? And Lab 82, as I told you. So the idea of CENF is to provide technological research for 82. It's an investment with FAPESP. FAPESP is the office to give us support in science here in São Paulo. And almost 4 million euro for CENF, and almost the same thing for Lab 82. And Lab 82 is a laboratory. It's specifically it's an infrastructure for experimental evaluation, okay, or validation. A little bit of CENF, okay. CENF has this structure. So thinking on hydrogen, we are working with hydrogen production, hydrogen storage, hydrogen applications, and hydrogen regulation, okay? And thinking on production, as Lilian told us, Brazil is a very big country. So we have possibilities with electrolysis, and we are doing research regarding to electrolysis, catalytic reform, also from residues, specifically from agricultural residues, or to provide hydrogen from catalytic reform, and bioprocesses also. We are doing research to produce hydrogen from vinasse, sugarcane vinasse, okay? Thinking on storage, we are doing research with high entropy alloys, okay, solid state storage, logistics, and high pressure storage also. And in applications, thinking on durability, connectivity, and fuel cell also. And regulation, specifically in Brazil, but not only in Brazil, because regulation is a very important topic for example, to export hydrogen. So we have people from our energy secretariat working with us on public policies and certification with people from Abeólica. Abeólica is it's a association that works with a windmill or wind energy. Okay, and it's important to say also that is a very huge or very solid management of the center. So the idea is to have a complete solution for example, intellectual property, communications, finance. So it's very important to make this administration very solid. Okay. So we have 50 researchers. So we have more than 90 people here at IPT. Okay, but we have 50 more researchers doing this research specifically on hydrogen. Some research highlights. We have sent running for almost 1 year, and then I would like to show you some results. Okay, for example, from dark fermentation or bioprocesses from sugarcane vinasse to produce hydrogen. Some data here, some data or some figures from biogas reforming, catalytic reform. Here, some results. Specifically talking about high entropy alloys, we have some very, very interesting results also to store hydrogen at very high densities inside the alloys. And one example from durability also to study, or they are dealing with research on the problems regarding to use hydrogen, for example, with metals and some oils too, okay, inside the internal combustion engines. Sorry, okay. Talking now about Lab A2 features and possibilities. At Lab A2, we have more than, we have approximately around 1,000 square meters. We have 2 HRSs, so we have a hydrogen production on an alkaline electrolyzer and a PEN electrolyzer also. Compression, we have both compressors for 450 bar and 900 bar. We have storage for both lines, okay, 75 kilos and 20 kilos, okay, of hydrogen at this pressure. And we have dispensers at these pressures to feed cars, trucks, bus, and other equipment also. And at this laboratory, we have also the possibilities to have inside the lab to run demo plants, to study mobility, as I told you, to develop sensors, components, chemical processes, and systems. And why? Because this laboratory has the intention to foster our industry, to make the hydrogen less expensive, okay, or to reduce the cost, especially capex costs and opex costs, okay. So we are fostering the industry to produce components here, for example. But with that hydrogen, we can also produce, for example, methanol or urea or something like that, because we have large quantities of agricultural residues here in Brazil, and we can put these things together, okay? I would like to show you a short video about the laboratory. I expect you have it running smoothly. Okay, this is one of our electrolyzer. This is a brand new, okay? And the idea is to use that electrolyzer in all those systems, like these compressors, to use it as a relevant space for industry to test some systems, for example, sensors, valves, every automation systems, and a lot of different possibilities that is needed to make a laboratory system. And here is the inner part of our lab. So it's a very big lab. And at these rooms, we will have some projects running. That's important to say that the idea of the inner part of this lab is to accommodate the projects. So that's the idea. Outside, we have the HRSs that you can put these things to test, for example, transducers or valves or something like that. And inside, we can run another pilot plants, okay, or demo plants. So these are some pictures of our inauguration. It's a brand new laboratory, almost 1 month, okay. And this the first picture at the left, upper left, we have the inner part of the lab, some pictures of our electrolyzer, compressors, the systems with some partners, trucks, and the dispensers. At the middle, we have a dispenser for 350 bar, and at the right, bottom right, we have the dispenser for 700 bar already installed. So, Kitos, that's our idea, and we are here, and I will be glad to hear something about it. Thank you.
Thank you, João, for giving us this opportunity to learn about some of the latest initiatives on clean hydrogen going on in the state of São Paulo, including the brand new Lab H2 at University of São Paulo campus. Thank you very much. We will have some space for some time for questions after the presentations. So now I'd like to move on to our next presenter, another João, this time João Bruno, who is going to join us from Bahia. He is from Senai Cimatec, the Institute of Research, Entrepreneurship, and Innovation of the Federation of the Industries of the State of Bahia. I'm going to briefly present him to you. So João Bruno Valentim Bastos is a chemical engineer with over 16 years of experience in industry and technology development. With deep expertise in applied research and innovation, he's led high-impact research and development projects across sectors like chemicals, oil and gas, healthcare, and bioeconomy. João has been the executive manager at Senai Cimatec since 2024. So please, João, thank you for being with us. You have the floor.
Lilian, good afternoon to our colleagues in Finland. Good morning to those who are in Brazil. I will put my presentation, my screen presentation mode. So let's go. I will show a little bit about Senai Cimatec and also what we are doing for the low carbon hydrogen development in Brazil. So Senai Cimatec is a pretty young institution in Brazil. We are only 23 years old, and we are actually an ecosystem where we integrate our main partners from industry, other companies, public agencies, startups, universities, fund agencies, and also other research institutes that's necessary to put those players together in order to develop technologies. So Senai Cimatec, we used to say that we are pushed by market. So industry, government, and the whole society push us in order to attend the demands that those actors have. And once we understand what are those needs, we look for partners and also for fundings in order to translate that needs in research projects, or also or and education and scientific research. We also have technological service areas, and sometimes those needs are related to new business development, what sometimes happen in the new hydrogen business. A little bit more about Senai Cimatec. We are achieving 2,000 collaborators. We are operating now in 2 campuses, but we are launching 4 more in the next years. And we are divided in 44 areas of expertise. Those technological areas, we organize those areas inside business, and I am in charge for the chemical and bioprocess business, where we, in partnerships with other areas inside Senai Cimatec, we run several different projects related to hydrogen. So a little bit more about our campuses. I said we are operating in 2. It means we have our headquarters in Salvador City, the capital of Bahia State, and we close to Salvador in Camaçari, where we have the petrochemistry industrial hub. We have an industrial park from Senai Cimatec. We are dedicated to scale up a sort of different kind of technologies, and we also have there our partners such as Ford Motors, who operate nowadays inside Senai Cimatec in Brazil. I will highlight those 2 campuses who are experimental, and give a little bit more information to our campus in semi-arid region, because we hope it will host also hydrogen production in order to use that in the value chains we are developing over there. So a little bit about our industrial park. We have there 4 million square meters and a dedicated area for piloting. And it's worth to mention again that this industrial park is inside an industrial hub. So we capture with that a lot of synergies, and we have a more facilitated process, for instance, in order to have environmental licenses and a license to operate technologies in a kind of scale that it's hard to do in a more urban area. A little view regarding our master plan for this area. So in this industrial park, we will integrate a science park where we are attracting scientific institutions to work alongside with us. And we in this area, we will also have a business park to host new companies that will be created, delivered from the integration that we are doing in this campus. And here in all over the campus, we have industrial facilities to test the scale up of new technologies. A little bit about semi-arid. We are developing a new value chain to produce ethanol from agave, who is already cultivated in this land, but the land is considered a non-really productive land in Brazil. So that is a transformation project. And we hope that we will be able to develop not only the ethanol production, but other products using other parts of the agave, which is the raw material that we are developing to be produced in that region, as we don't have rain high incidence of rain. This, so we must develop a culture that can grow up without a lot of water. We have strong international collaborations, also in Africa, North America, Europe, and Latin America, and also in Asia. This year, we launched our office inside the Energy Transition Campus, Amsterdam, that is hosted by Shell. Being present in Europe to facilitate the partnerships that we want to make in Europe in general. So going straight to hydrogen subject, which is the main subject of our discussion, in the COP28, we launched an atlas for map the potential for the production and use of hydrogen in Bahia State. Bahia State has a huge potential for renewable electricity generation. So if we have that, and we also have a huge availability of water, we can be a strong player for the low carbon hydrogen production, especially, of course, using electrolyzer systems. But we are also looking for other kind of technologies that might use also considerable amounts of electricity. And for instance, we found a potential that can reach 84 million tons per year of green hydrogen production. And even if we use only a fraction of this potential, it is still a huge potential for product hydrogen, low carbon hydrogen in Bahia State. And once we have this kind of map, we have valuable data to work based on. So our approach is once we have informations, we have data, we can map the potential value chains and the technologies that must be used in those kind of value chains. We used to say that we use technical economic analysis, including all kind of environmental analysis to assist our R&D process in order to have a kind of support decision tool where we support all level of decisions that must be done in such kind of high capex and high risk projects. With that, for instance, we model based on the rigorous representation of technologies, we model the economic finance scope for the technology, and then we are able to calculate all the indicators that's necessary to provide information to decision, not only regarding the investment for those kind of business, but also it guides the R&D process by itself. When we are talking about new value chains, new products, mainly based on renewable resources, to understand the scale is very important. So using also those kind of tools, we try to understand which minimum scale is necessary to give competitiveness to this kind of new products. A way to show how we work in Senai Cimatec, we integrated in our ecosystem basic research, R&D, and also commercialization support. So we need to balance the profile of the professionals that we work in the project depending the maturity stage, the development stage. So doing that, we hope to bridge the gap in the valley of death of the technology development, because we synchronize each stage of development with the high profile that's necessary to address the main challenges that we must address in each stage. And we know that the technology development usually bore and usually are initially developed by researchers, by PhDs, by masters, but in some ways, in some point of the process, it must be converted and given to and have leaded by engineers and technicians, because once we have the technologies in a bigger scale, we must have operators, we must have a logic of operator close to what we have in really industrial and high scale facilities that operate in industries. We with the academic partners that we have and other ICTs, we divide the leading of the process regarding this based on TRL. What we have in Sinai Cimatec, we see ourselves as a main player for the applied research phase, and especially to support the scale up of those technologies. Doing that, we hope to bridge this gap. And another way to see, and I think that it's also worth to mention, is once those industry and those technologies are developed, we will need professionals to work that, to operate those facilities. And if we don't take care about that alongside, and while we are doing the development, there is a risk to have the technology and don't have at the same time the workers that we will be needed to operate that. So having the professional school, the technical school inside Senai Cimatec, and also an university, we can synchronize and plan the preparation of the workforce alongside during the technology development, in order to have those professionals ready to operate the facilities since the pilot units. Another way to see that is that we need to translate the activities from R&D approach to engineering the operation approach without any kind of troubles during the technology development. Again, hope bridging the gap of the valley of death. Some examples what we have right now. So as I showed, we developed an atlas to deliver data for green hydrogen potential production here in Bahia. We are building a green hydrogen hub in order to support the developments that must be done, not only the production, but in all value chain of the hydrogen, low carbon hydrogen production. We launched a few years ago an MBI, a Master Business Innovation in Green Hydrogen, that is being a very successful initiative. We have formed right now 3 groups so far, and we also developed an internal competence center in green hydrogen, exactly to prepare people that must work in those kind of projects. So an example of the lab, that the pilot lab we are building right now. So we installed all the photovoltaic electricity generator. We have a BESS system. We have also the electrolyzer, the compressors, truck fuel station, and we also simulate the industrial use and also the possibility to carry hydrogen using ammonia. And also we are testing oxy-combustion in order to use the oxygen that's also produced alongside hydrogen. Just few pictures. This is our electrolyzer that is already installed in that facility, and we are planning to launch the facility next month, in maximum at the beginning of 2026. This is an example of a project that we are joining as Senai Cimatec, but is being developed inside the Senai system. which is related to use low carbon hydrogen in order to produce products, in that case, an F-fuel, e-fuel. And this unit is also running in Brazil, producing 20 liters per day of a synthetic crude. This is a picture of this unit. And for instance, we are right now actualizing this facility in order to test either the hydrogen production from electrolyzer pan, and also, for instance, using plasma pyrolysis of methane and biomethane to produce low carbon hydrogen. To finish my presentation, I would like to share a big picture regarding the whole value chain to produce, regarding the biorefineries that must add value to raw material that must come either from agroforest industrial system and other from high scale biomass production. And hydrogen is an input that is strongly necessary for having this kind of concept developed. And we are dedicated in Senai Cimatec to develop this concept, to work in ceasing the micropropagation and the development of new cultures until to the biorefineries. I think that's it. I'd like to thank you a lot, the Brazil Finland Embassy, to the invitation, and we are looking forward to the discussions that we have today. Thank you.
Thank you very much, João, for giving us this perspective of the Senai Cimatec Park, of the international initiatives that you have there, and also on the clean hydrogen projects. And when it comes to Brazil, it's such a large, diverse country, it's very important that we have the perspective from different parts of the territory. So thank you for giving us a perspective from Bahia. Okay, so now we are going to our next speaker. He is from Aalto University here in Finland. He has strong links to Brazil. He has received his PhD degree from the São Paulo State University, Unesp, and he will tell us, among other things, about a collaboration between Aalto University and UniABC, which is the Federal University of the ABC region in the state of São Paulo. Mahdi Purakbari is an assistant professor at the Department of Electrical Engineering and Automation at Aalto University. He is responsible for the electric, energy, and hydrogen systems major at Aalto, and is the leader of the Aalto Power and Energy Systems group. So Mahdi, thank you for joining us. You have the word. Thank you.
Hello, thank you very much, Lilian. Thank you for inviting me. This is a great pleasure for me being here and also providing some information that what we are doing at Aalto University. Okay, do you see my screen? Yes?
We do, yes.
Okay, perfect. Thank you very much. Okay, so I'm Mahdi Purakbari, as Lilian introduced nicely, Assistant Professor of Power and Energy Systems. So I'm going to provide a bit information about collaboration opportunities, systems perspective that we have here in Finland and also in Brazil. So a bit about Aalto University, and then carbon neutrality, and then how the integrated energy systems works and what we are doing there, and what is the current and upcoming collaborations with Brazil. So quickly about Aalto University, is the merger of three universities, and has been founded in 2010. It's a measure of business, art and design, and science and technology universities. And the idea is to was to have a hub, a very close collaboration between these three entities, so that we can develop and provide better solutions for the society. And I would say it's working very nicely this way. So if I open the hydrogen activities at Aalto University, so we have Aalto Hydrogen Innovation Center, and the target is to have a closer collaboration between Aalto University research and also with the companies, the policymakers, those who are working actively in this area of research. And then in order to have our experts for the future in the hydrogen and electric systems, we just launched a new program on hydrogen, which is a link between hydrogen and electric system. It's based in a School of Electrical Engineering. And the idea is to prepare experts that know how to develop, how to understand, how to investigate the system level connections, system level interactions, and also have a good understanding of the component level. From dynamic studies to steady state studies of those systems. But now, if we look to the carbon neutrality concept and also what is the goal of Brazil and Finland, and then we start from here, we see that in Brazil, the goal is to reach to this carbon neutrality by 2050, and in Finland, it's by 2035. But by 2035, Brazil has a very a large scale country, so up to 67% is a very ambitious milestone, I would say here. But then we need to be a bit focusing on the concept of carbon neutrality as well, because I'm hearing sometimes carbon neutrality, carbon-free society. So we are focusing on carbon neutrality in which we can produce, we can emit still the CO2 into atmosphere, but we need to capture, we need to reduce and remove the same amount. And then we are doing these kind of studies from the technical perspective and also from the nature, sea, ocean, and also forest approaches. We have also some experts that they are going to understand what will be the capture capacity of those nature. And then I strongly believe, and also we believe at all, that it cannot be achieved, this carbon neutrality, if sectors, electricity, gas, hydrogen, traffic, district heating and cooling, they move alone. And I would expand it a bit more. This carbon neutrality globally cannot be achieved if countries move along. So we need to collaborate always, and we need to understand what are the main points of collaboration here in Finland and there in Brazil. So that's the idea of this presentation practically. If we look to the hydrogen sector, we have electrolyzers. So they are taking water and they are splitting into hydrogen and oxygen, and then we are focusing on hydrogen here. But clearly, we need the electricity for that. So there is a link between electricity and hydrogen here. And once we are thinking about transportation, transmission of hydrogen, or storing hydrogen, or hydrogen for refuel stations, indeed we need compressors. So it is vital to understand the steady state operation and also dynamic aspects of electrolyzers and compressors as well. So this is one focus that we are having at Aalto, and also modeling the joint electricity and gas or hydrogen systems is another focus here. So of course, based on our understanding, hydrogen sector will become the largest user of electricity, But what we need to focus is the interaction that exists between hydrogen and electricity sectors. So they cannot move alone. They are already interlinked with each other. Now, if we look a bit closer to this sector, once we are using electrolyzers, compressors, and etc., there will be some heat byproduct there. Then heat byproduct is something that we can capture. Heat is something that we can capture. Sometimes it is called waste heat, but I prefer to use byproduct because we are finally using it, recovering or reutilizing it, or using for the district heating, for example. This is the idea that we can capture the district, the heat and use it in district heating in Finland, but obviously this is not the practical case in Brazil. But of course, we have a lot of experts here at Aalto in Finland about how to reutilize heat that can enhance the total efficiency of the sector. So this is something that some kind of knowledge that can be transferred or from one country to another country, for example. But thinking about the heat capture, storage, and usage and utilizing in district heating, we need to be careful about the efficiency, because the remainder of the efficiency, if the efficiency is 70%, around 25% will be byproduct heat. So we need to do some feasibility analysis. What if in future the efficiency increases? Should we still plan for having this byproduct heat in district heating or not? So that's the kind of uh, uh, also time-based analysis. But again here, as the hydrogen is a bit far, by 2030, 2035, we are thinking to have the plan in place. So electrification is in focus, but on the other hand, there is the interaction between hydrogen, electricity, and district heating. So again, they cannot move alone. So they are interconnected, interlinked together. Quickly about the transport sector, if we look to the statistics, it shows that the hydrogen, it's the sales in units. It used to increase until a moment that it has decreased. Why it's so? I will explain a bit more. But about the plug-in electric vehicles, then we see that it is increasing always, and the scale is millions. But this is about mainly passenger cars. What we are thinking about transport is electrification for passenger cars, H2 for port and heavy duty transport. So H2 for port and heavy duty transport is another aspect that we are collaborating with Brazilian University of ABC, that I will open it a bit more. But here we see clearly the interaction between H2 electricity and transport sectors. Again here, so this is the main reason that I was mentioning, that we cannot move alone. The sectors cannot move alone. And our idea is to have, and actually we have a part of the model of a Finnish hydrogen network. So we simulated that, and we studied some flexibility analysis of that. And this is a kind of knowledge or understanding that we would like to transfer to our Brazilian collaborators. And then in return, I will speak what we will receive, which kind of knowledge from Brazil we are receiving there. As a very quick concluding remark, we see that electrification and efficiency are the key drivers of clean transition, but renewable energy and clean hydrogen, of course, are its enablers. So this is the main reason why we are focusing on clean hydrogen. But looking to the general perspective of clean hydrogen projects, only 5% of the accepted projects in H2 show moderate potential for 2030 operation. This is not good. And what are the reasons? Uncertainties, future evolution of demand, lack of clarity of certification, regulation, that I think Timo will also explain about this, and lack of infrastructure available to deliver hydrogen to end users. And of course, lack of experts. We need to collaborate together to have experts who can work not only in one place, but also can transfer knowledge to other places. And a very quick comparison of or highlights of H2 in Brazil and Finland, it is clear that we have the same approaches. Export is in the focus. And then I highly appreciate the kind of public investment increase in research that I found that Brazil is uh, doing that. So we need research for a field that we need experts. And the main focus of H2 uses, so we see that there are some differences. For example, byproduct heat cannot be used in district heating because in Brazil, there is no such a concept in a broad area. But then ammonia is something that Brazil is focusing on. So this kind of knowledge can be transferred to the ammonia production, export, and etc. And then about the operation, we see that in Finland, it's 20 megawatt of green hydrogen is in production, but the focus in Brazil is more toward the hub pilots industrial project advancing at ports. 3 important ports, you see the names here. But very interestingly, if we focus on the generation and demand concentration in Brazil and Finland, we see that we have the same challenge practically. In Finland, the focus of generation is in this part, and the focus of demand is here. And in Brazil, the focus of generation is here, and the focus of demand is here, or the concentration of demand is here. So long transmission or transportation distances. We need to think very carefully how it works. And if we find a solution that works, for example, in Brazil, we can somehow borrow that and use it in Finland, or Finland, which is now thinking about these kind of activities, this kind of knowledge can be also transferred there. But what we are doing at the moment, so we have one project which is Find Braze H2, which is Finnish education, Brazilian education on H2. So that was a proposal, and thanks to Team Finland Knowledge, you can find some information about TFK here, and thanks to all motivators and counselor of education at uh, Finnish consulate in Sao Paulo that motivated us to prepare a high quality. And then we started from here, but we are not staying there. And the main idea is that we have hydrogen and electric systems here. We are going to transfer the knowledge there, and perhaps a H2 curriculum expansion will be done also at University of Federal University of ABC. And also we are trying to prepare one intensive or 2 intensive courses, not only for uh, our researchers in universities, but also for industry people, those topics that they need or they would like to understand better. And also we are thinking about more future collaborations like dual degree, and also we are having some mobilities to strengthening this idea. And next steps here will be that we are now we prepared actually a proposal on designing hydrogen corridors for heavy transport, and also we are thinking about grid electrolyzer bunkering co-optimization at ports that can be used. We can use the knowledge of experts in Finland and also knowledge of experts in Brazil, and by the very close collaboration that, for example, Federal University of ABC has with petrochemical hub, we can also bring some real cases, real case examples to Finland. So as a concluding remark, knowledge transfer plays a key role in overcoming the uncertainties and moving forward with this clean transition and the difficulties that we have. And then I would say together we are always stronger. Thank you very much.
Thank you very much, Mahdi, for sharing with us your knowledge on the subject and for the comparative perspective of Brazil and Finland. And also, of course, for the information on the ongoing and future collaboration between Brazil and Finland. That's great news for our countries. Thank you very much.
Yes, thank you very much.
So now we are moving on with this academic part of our webinar. And I'll pass the word to a participant who not only has strong ties to Brazil, but is a Brazilian, developing cutting-edge research on clean hydrogen here in Finland. I am sure he will bring us incredible insights on the topic. So Pedro Camargo, he's a professor of inorganic materials chemistry at University of Helsinki, where he leads a research team developing sustainable catalytic solutions for green hydrogen production and carbon dioxide conversion into fuels and value-added chemicals using sunlight as a clean energy source. His research has been supported by the EU Horizon, the Research Council of Finland, Novo Nordisk Foundation, Business Finland, the Finnish Ministry of Defense, and the Jane and Atos Erkko Foundation. And he is also a member of the Brazil-Finland Innovation Network, which is coordinated by the embassy. So Pedro, welcome. Thank you very much for being here with us, and you have the floor.
Thank you very much. I hope everybody reads me well, so can hear me well. So I would like to start by thanking the organizers for the invitation. So my name is Pedro Camargo. It's an honor to be participating and representing the University of Helsinki in this webinar. And here today, I'm gonna try to talk about how we can connect sunlight and snow, a metaphor on how we can connect Brazil and Finland, our two countries with very different climate, but with very similar shared goals. So while you start by talking a little bit about like the Finland hydrogen ecosystem, then I will talk about some of the research that we do at the University of Helsinki and in our lab specifically, and then I will finish with some opportunities for collaborations. So if we look at the hydrogen value chain, as it has been mentioned before, it becomes clear that hydrogen is key to the decarbonization of our society. So not only we can use hydrogen to store renewable energy, but also we can use hydrogen to decarbonize hard to abate or hard to electrify sectors. For example, green hydrogen unlocks and enables green steel, green ammonia, which in turn goes to green fertilizers, and also unlocks e-fuels. And there are other potential applications in the transport, heating, and power generation as well. So in terms of Finland's vision and capabilities, Finland has very ambitious goals, for example, aiming to deploy 5 gigawatts of electrolyzers by 2035. Finland has, I believe, a very strong research, development, and innovation ecosystems in which industry, research institutes, and universities work together to develop technologies. And the national themes from Finland, materials, digitalization, and sustainability, are perfectly fit for the green hydrogen research and future green hydrogen economy. and enable us or give us the tool to move from lab to pilot and then to market. And Finland is already very well organized to work on these goals. For example, we have the hydrogen cluster in Finland that brings together more than 60 industrial and regional projects involved in related to clean hydrogen. These projects are expecting to a reduction of 17 megatons of CO2 and have a predicted very large electrolyzer capacity. And then we can see in this map that these projects expand like from north to the south of the country. So north, where all the potential for wind energy to be generated, to the south, where the industry hubs are. In terms of research, we also have the hydrogen forum, which connects all the major or most of the major research institutes and universities in Finland, collaborating and having this single vision regarding research on green or clean hydrogen. And this, in a way, already demonstrates that collaboration is part of the Finnish DNA for research in this area, which is excellent. And most recently, a very exciting initiative that has been established is the Hydrogen Springboard, which is an ecosystem initiative led by the company ABB. So this has been supported by Business Finland with an investment scope of over 150 million euros. And the goal is to create the world's most competitive technology development in green hydrogen in Finland by connecting universities, companies, and startups. All right, so this is an overview of the big picture in Finland. So at the University of Helsinki, we have our Helsinki Hydrogen Hub that I am coordinating. So in this hub, we are trying to address like fundamental research and also some practical innovation in the entire scope of the hydrogen value chain. And with this, I mean production of green hydrogen, approaches for the storage of green hydrogen, and also utilization, and of course, working on the education aspects as well in our bachelor and master's program. And then this hub brings together the chemistry department, the physics department, and also the geosciences. So chemistry for materials development, research on new improved catalytic processes, physics, a lot of activities related to advanced characterization and also hydrogen storage approaches. And in the geosciences, we are interested, for example, in the geological hydrogen production and also geological storage. So if we take a look at this big picture of this whole picture of the hydrogen value chain, here we have the electrolysis step, which is the step in which we use an electrolyzer, which is the equipment that enable the production of green hydrogen from water, and this is powered by renewable electricity. And this is where the focus of our research group is, and this is what I particularly am more interested in. So I think this is one of the most exciting challenges in terms of green hydrogen. So in the electrolyzer, catalysts are needed to be used. So the catalysts in an electrolyzer enables the production of green hydrogen. So catalyst is the substance inside the electrolyzer that make it possible that we turn water into hydrogen. And the key challenge here is that some of the technologies to produce green hydrogen, for example, the use of the PEM electrolyzers, require the use of scarce and expensive metals in the catalyst. More specifically, current PEM electrolyzers require the use of iridium. Iridium is very scarce, very expensive, and another important issue about iridium is that it is geographically concentrated. Over 85% of all the reserves are concentrated in South Africa, which means Europe is 100% dependent on imports. So in one of our projects, this project is specifically called Relight, funded by Business Finland, we are doing research to develop catalysts that enable us to drastically reduce the amount of iridium that is used. So for specifically, we have been able to cut iridium use by 80% in these kind of technologies, which is a very massive reduction. So here we can see, like very briefly, some of our results here validated in a lab scale electrolyzer. So here I'm showing results for a catalyst in which the iridium content was reduced by 50%. So we achieve high current densities and acceptable stabilities compared to the commercial benchmark. We achieve this by doing an advanced control and design of the nanoparticle features that make up these catalysts. And now our production of these catalysts, all our approaches are based on methods that are easily scalable in the future in case these catalysts are successful. And here we have our electrolyzer producing hydrogen in the lab in operation. In addition to this conventional hydrogen generation by conventional electrolysis, which is the state of the art today, our group is also a pioneer in a field called plasmonic catalysis, which is a field that enables us to use visible light or even sunlight as a sustainable energy input to further accelerate molecular transformations. So this can also be applied for green hydrogen, and this enable us to reduce the need for external renewable electricity to power green hydrogen production, and also break these conventional efficiency limits, which can pave the way in the future for cheaper green hydrogen, which is one of the challenges of the field. And then we are developing a portfolio of intellectual property and patents covering catalysts for conventional electrolysis and also plasmonic catalysis, which we believe could be one of the next generation technologies for the production of green hydrogen. So looking at this, our mission, therefore, or our main goals are to develop sustainable catalysts and catalytic processes for green hydrogen production and use, to use light or sunlight and renewable electricity to increase the efficiencies of these processes, and develop low-cost, efficient, and durable materials to power these, and then with this big goal of using these to help to drive the transition to a more carbon neutral society and circular economy by using green hydrogen. So more specifically, our workflow, and then here collaborations with Brazilian partners are, and also Finnish partners, and are welcome in any of the areas of this workflow. So we start with some computational discovering using modeling and machine learning to guide catalyst design and guide catalyst compositions. Then we proceed to their development in the lab, their synthesis, the study of their features. Then we do the lab scale benchmarking, in which we do structure performance relationships. Then we move to device level validation, which is like a more close to industry relevant conditions. Then we go to we use the data to as a feedback back to computational discovery, synthesis, and benchmarking. And then we also try to work with external partners, real industries, for the validation of our catalysts in real world conditions. So here are some examples of results in some of the stages of this workflow. So here's our machine learning workflow. Here's a picture showing how the models that we develop match experimental procedure, experimental data, and the quality of the models. Here are some modeling of several high entropy alloy catalysts with different absorption sites and energies. And then here is a result of how this can be used to guide catalyst synthesis and achieve high performances. Here is a picture showing some of the advanced characterization of the catalytic nanoparticles that we produce, how our catalyst here can achieve superior performances relative to commercial benchmarks, and how we use modeling to understand these activities as well. And then lastly, we have here our lab scale electrolyzer, which we use as a device level validation of our catalytic materials. Here's how we assemble the electrolyzers in the lab. Here's a picture of the electrolyzer that we have. And here we have the performance and durability of one of our catalysts. So how we can connect Brazil and Finland in practice, I think through 4 main areas. So having joint projects on research and joint projects on innovation, promoting more research and student exchanges, education and training programs. I think it was also mentioned is like dual degrees, creating science-driven innovation hubs and clusters, and industry partnerships, and also developing perhaps some joint policies. So I believe there is a huge potential for collaboration and coming together. I think both Brazil and Finland have strong technology, strong talent, and a strong determination to achieve great things. So I think if Brazil and Finland meet on this, we can really make a difference in the future hydrogen economy. And I propose that we could, as next steps, form a working group to coordinate these collaboration efforts and start by launching some research, some joint research projects and promoting exchanges for students and industries. So thank you very much. I would be very happy to continue this conversation on future collaborations and future opportunities. So please free to reach out. Thank you very much.
Thank you very much, Pedro. It was very nice to see those concrete suggestions on how Finland and Brazil can collaborate on green hydrogen, and you make us very proud with your work. Thank you very much. We will now invite another Brazilian participant. She's also a member of the Brazil-Finland Innovation Network, and she has been developing important research concerning green hydrogen and renewables in Finnish academia. Last week, she was a keynote speaker at the Hydrogen Research Forum Finland at Tampere University. Mariana Galvão Lira is currently affiliated with the Lappeenranta University of Technology Business School as a postdoctoral researcher and project manager. With a career that bridges consulting and academia, she works on topics at the intersection of business and society. Her current research focuses on the social acceptance of emerging technologies for energy transitions, particularly green hydrogen and power-to-X solutions. And she will share a little bit of her work with us today. So Mariana, thank you for being with us. We are all ears. Please go on.
Yeah, thank you, Lilian. Happy to be here. Let me learn how to share my screen.
Okay.
Yes. Okay. Mm,
You can go to the down bar.
Let me see. Um, yes, I think I did it.
Filter screen. Okay.
Yeah. Can you see it?
Yes, we can.
Is it in presentation mode? Don't know.
It's the whole screen right now.
Okay. Okay, not. I took it out. But now.
Let's wait a bit.
Yes?
Yeah, we can see the presentation, but not in presentation mode, but just
Funny. Okay. Anyway, sorry for this
no problem.
technical problem. I'm gonna stop sharing and do it again.
Okay.
Maybe now?
Yeah, it's the same. Okay.
Okay. Well, let's do it this way then. It's not a
We can see
problem.
it. We can see it. Okay.
Yeah. So thank you, Lily, for the introduction. And as you said very well, I work for LUT and I work with the business school. I'm happy to be the only woman presenting here today. Not only that, but the only one talking for the social science and humanities perspective. So it's a challenge, but also is a pleasure because that's one of my goals in Finnish academia is to bring the social humanities and social science and humanities perspective to technology, to experts. So that's what I'm going to talk today about. So I work at the Green Renew platform, which is, let me try to put more zoom here, if I cannot put on presentation mode so that you can see my slides better. Does it change anything? Yeah, maybe. So yeah, so I work for the Green Renew platform, which is a multidisciplinary platform at LUT. That means that we work with the business school, with engineers, chemists, and so on and so forth. And this platform was built exactly to focus on green hydrogen or clean hydrogen solutions, and also this power to X solutions, which means the technologies that are related with pretty much what Pedro Camargo just explained to us. Meaning X are any type of solutions, pretty much synthetic fuels, and ammonia is used as a fertilizer. But yeah, so these are the topics that they are developing and working on, and what we do is to support from the business school point of view. So I think Madri also talked about what's going on in Finland, and I think for many different type of reasons, green hydrogen became very strategic for Finland, and there is with the government the goal to produce 10% of whole Europe green hydrogen in 2030. So this is a very serious commitment, and that's why I believe that it became also strategic for us academics to focus on green hydrogen. So I'm gonna bring some of the projects that we've been working on with LUT. Hugsal is one of these projects, and it was pretty much about value chains on from the renewable energy to producing green hydrogen till the power to X solutions. And this project was pretty much a big consortium involving not only LUT as a university, but different universities as well. And because we are a technology university, we work pretty much very close to companies. So several companies were also involved in this particular project, and it was a Business Finland project. We worked particularly with the business school on social acceptance of synthetic fuels. We ran a case in Lappeenranta, and in a few minutes I'm going to talk a little bit about the results from this project from the social acceptance point of view. Another project that I've been involved with is the Power2X Infrastructure Lab. Again, a project financed by Business Finland, and again, a project involving different type of companies and very closely in collaboration with companies. The lab got ready in May earlier this year. And this project is ending in December. And with the business school, what we did was to work with the digital part of this lab. And we have run some 4 fast expert teams. And one of them pretty much focused in hydrogen and Power2X in Finland. And what we did was to do 80 background interviews to form 6 expert teams and put these people to talk during a specific amount of time, which was 4 weeks. And within this time, they try to solve one task or one problem connected to Power2X and green hydrogen. And they came up with 8 concrete actions, and some of these actions went beyond this time, which was pretty much the goal in terms of policies, in terms of acquiring new funding, and this is how we've been working not only with green hydrogen, but in several other energy projects from the business school when collaborating with engineers. This, like, coming already to the more research part of what I do. So these 2 projects were more in the managing part, but when it comes to the research part, recently we collaborated with 2 book chapters in this very technical book, a textbook for energy engineers. So Mika Havinen from Aalto, actually, he had this great idea together with Hanna Palomäki to make this book in which not only engineers will make this textbook for engineers, but people like anthropologists, social scientists, business, with many different type of backgrounds would be included. And I participate with the wind and renewable energy chapters. So it's a very thorough book that has been downloaded 40,000 times so far. It's open access, so it's a very nice tool to advertise always. And also, I actually very happily wrote the social acceptance entry to the Encyclopedia of Innovation Management. I used both of these 3 book chapters to prepare this talk today. And now I believe finally I get to social acceptance, which is pretty much the focus of my talk, or the second half of my talk. But I would like to invite you to, instead of thinking about social acceptance, let's think about perceptions in a way of how people think, how people form their opinions, how people feel about new projects and new emerging technologies connected to energy. And this invitation is because after working with energy for a few years, I realized that the word acceptance has embedded this idea that it's quite binary, whether people accept a project or not, whether 100% support the idea or not. As such, is a quite crystallized concept. And then when we think about perceptions, it's something more fluid, more plastic, and changes over time. And that's pretty much what social acceptance is about perceptions that change over time. And as such, is something that we can influence, right? We can also influence perceptions over time. So this has lots to do on how we communicate science, how we engage with public, with different types of stakeholders. And that's a part of the game that, in my opinion, at least here in Finland, I cannot speak much about Brazil being working for 12 years in Europe, but that's still a lot to do. And that's where I'm going to give my 5 cents to. So I'm going to bring some previous studies here. The first one talking about social acceptance of hydrogen and getting pretty much puzzled results. So this one is green hydrogen acceptance in Germany. And the results were that people have limited knowledge, but a very big or strong openness towards green hydrogen. But they had the expectations also that these projects would bring environmental benefits. So in a nutshell, what they were talking about a lot was about trust. People needed to trust in science, in the government, in media, in institutions. And another important results from this study is how much the participatory process influence on people's acceptance. So the more people feel that they would be engaged in the process, the more active could be their support. And repeated positive participation would also solidify trust over time. So to bring people to the center of this process and to make them to have more participation is key in building trust. And that's also what a study in the UK found out. So they put people at the center of the discussion. And for lay people, or for when we start talking about business and society or energy and society, usually the first thing that comes about when we talk about hydrogen is safety. And this study found out that safety actually was not leading to total opposition, but people were more interested in see real life hydrogen applications. And one of the recommendations of this study is how education or well-known figures could help to give more legitimacy to hydrogen. Now a study a little bit from closer to Finland, from Norway, linked a lot the economy or economic narrative to the environmental one. So there was this integration when they asked people about hydrogen projects. And there's a quite positive perception, 3 times more than negative ones in Norway. And energy costs are now emerging as one concern in public discourse, which was not the case in earlier research. So what about Finland? So what do we know so far? So this is a paper that it's under review at the moment. It's the case that we did here in Finland, a synthetic fuel plant in Lappeenranta region. We did a survey and we split acceptance into 2 parts. So how in general people would accept hydrogen as a technology, and how much people would accept a hydrogen plant close to where they live. What we found out was that the more people felt they understood about hydrogen, the more they would be keen to accept the technology. And the more they would have actual factual based knowledge on hydrogen, the more would be fine with them to have a facility closer to where they live. So what does it mean? It means many things, but the overall sentiment is positive. But what I would like to talk about a bit today of what it means is about the need that we have, and here I include myself, to translate this pretty much new and technical knowledge on hydrogen and power-to-X solutions to a way that different type of stakeholders, especially community stakeholders, can understand it. Because the more they understand, the more they will accept. I'm not advocating for fully acceptance. This is another discussion that I'm gonna come about in a minute. But nevertheless, I cannot emphasize enough the need to translate the technical knowledge to more lay terms, to different type of stakeholders via different channels in different formats. So another point that to facilitate that, or that to me was new when I was doing some literature review, was this. Of course, safety is an issue when it comes to hydrogen and power-to-X, but it's not an issue that is definitive for acceptance. But visibility and experience is a very important issue and conditional to acceptance. So how can we think of ways to bring green hydrogen and power-to-X closer to people when we are talking about mobility, when we are talking about the hard-to-abate sectors like green steel? If we talk about buildings, it's a little bit closer. When we talk about the fertilizers, the green ammonia, it's easier when we talk about agriculture, when we talk about food made out of clean energy source, for example. And in the Brazilian case, which I don't have so much experience in, but I am developing a paper right now, I'm conveying the idea that social acceptance does not occur in empty territories in Brazil. Brazil is a very different case as a society than the Finnish society, than many European countries, which that like, especially in these megaport projects that are coming about right now, many of these local territories have experienced in the past not so positive relationship with companies, and in a sense, it's very important that we bring more diversity and more inclusion to the table when discussing these ideas, when going further with projects, so that we can have the local community's input as well when we are developing these green hydrogen projects, because one of the big umbrellas for green hydrogen is the energy transition, in which one of the thumb rules is that the transition has to be just, right? And on that note, I will just leave you with the recent publications that helped me out to make this presentation. And I believe that soon we're gonna go to the Q&A, and I think my time is up anyway. So thank you very much. And if you have any questions, I'm here to talk to you.
Okay, Mariana, thank you very much for bringing us a different view on hydrogen, one that incorporates the social perceptions and the public acceptance of new technologies. Yeah, so now we've come to the Q&A part. So if you have questions, please, you can write them down on the chat. I think for now we don't have any questions. So I'd like to ask you, if you have questions later, if you'd like to send them later, you could send them to this address. It's the Science and Innovation Sector email, so sectec.helsinki in Portuguese, @itamaraty.gov.br. We're going to leave it there for you. And yeah, you can leave it for some more time. We do have a question. Great. So let's go. Arthur Sales. Morning, my name is Arthur Sales, and I'm finishing my PhD in Regional Policy and Economics at the University of Pech, Hungary. The Ceará state my hometown in Brazil, has been developing strong renewable energy initiatives. I'd like to ask whether there are plans for postdoctoral or research opportunity within this Brazil-Finland cooperation, and if this might include areas beyond technology such as regional, agricultural, or environmental economics. Kiitos. So yes, I believe this question is directed to Mahdi, maybe?
Okay, so I think mainly the question was about areas other than the technical parts, but then of course, yes, if I focus in our collaboration with Brazilian partners, yes, we are thinking on writing a project that we can have postdoc on that as well, but still we need to wait because now we just started writing a proposal together.
Thank you, Mahdi.
Thank you.
If Mariana, would you like to say something about it too? Or okay, now we have another question for this one is for Mariana is asking a question actually. I have a question for João and both João Bruno, João Valentim, and João Cordeiro. Are the demo pilot plans open for people to experience it as well? João?
Hey, Mariana, thank you for your question. Actually, we have some issues regarding to safety. So if you if the people are well trained on these things, I think we can put it on projects, and then the people can experience it as well. But I think it's another point. At IPT, for example, the next days we will have some planned visits to our laboratory also, because for us it's very important to have people looking at the technologies and seeing the technologies. Okay, so in this way, to visit it's working. A pilot plant is there is a lot of safety issues, so we have to make our boundaries very carefully, but to know or to see the things happening, yes, it's possible.
Thank you, Mariana, for the question. As João said, I think our facilities are the same. We are always concerned about safety issues. But as we have a big space over there, we have a kind of tour where it's possible to see the facilities not too close, but also it's a good view. And side projects, and with having all the trainings and the preparations, of course, it's possible to even work inside the facilities. But different from IPT, which already launched the facility, ours in Senai Cimatec is being finished. So we are expecting to launch the facilities the end of this year, next month, or maximum at the beginning of 2026. Only few details are missing to launch also our facility here.
Okay, thank you very much, João Cordeiro, João Bruno. Do we have any more questions? Maybe we have time for one more. Well, but yeah, I don't think so for now. So yes, you can still send questions to our email. And we had some greetings here from Finland, so, and also from Brazil. So in Brazil, we had like greetings from Piauí, Pindamonhangaba. We had greetings from the universities of Helsinki and Aalto, from Vaasa, from the Hydrogen Cluster Finland. So thank you very much for being here with us and attending this webinar. So yes, now we are going to skip the break because we are a little short of time. So we are going to go back to what was supposed to be the first part of the webinar. We have been trying to connect Timo Ritonumi, who is the Deputy Director General in the Energy Department of the Ministry of Economic Affairs and Employment of Finland. Unfortunately, due to some technical problem that we couldn't identify, I don't know if we can at least hear you, Timo. Could you please try to say something like, but I don't think we will be able, unfortunately, to have Timo's participation right now. He was going to join us from the airport on his way to an event. So something unfortunately didn't work. So we would like to thank him very much for the effort. We have his presentation and we can share it with those who have registered for the webinar. And so we will move on to the other governmental representative. So now we will give the floor to Osório Coelho. Osório, thank you very much for waiting for your time. Sorry for this change of plans, this sudden change of plans. So Osório is he currently holds the position of Director of the Department of Innovation Programs and Deputy Secretary for Technological Development and Innovation at the Brazilian Ministry of Science, Technology and Innovation. As I told you before, but let's remember now, he previously held leading positions at the Ministry of Science, Technology, Innovation and Communication, at the Civil Cabinet of the Presidency of the Republic, and where he was the technical advisor to Science and Technology Working Group during the Brazilian government transition. So he will present to us the integrated approach of the Ministry of Science and Technology of Brazil on hydrogen and innovation policy. Please, Osório, the floor is finally yours.
Thank you so much. Can you hear me well?
Yes, we can.
Okay. So I am very sorry for this technical issue, but this is quite normal when it comes to the Science, Technology, Innovation Ministry. So, can you see my screen?
Yes, we can.
Okay, so I will put in presentation mode. Okay, so thank you again. So good afternoon for the Finland friends and good morning for the Brazilian friends. I am here representing the Brazilian government, specifically the Ministry of Science, Technology and Innovation. So it's a pleasure to be here today participating in the session. So I will talk a little bit about what we in the ministry are doing regarding the hydrogen topic, regarding innovation and also industrial decarbonization. So I will present how Brazil is structuring an integrated approach that links science, technology, and innovation. Also, I will say a few words about our funding and having hydrogen as their strategic pillar. So some early references here in hydrogen in Brazil. Brazil's involvement in hydrogen research dates back several decades, particularly in studies related to fuel cells and hydrogen system. So this is not a new topic for the Brazilian government. So these early academic and pilot projects, they help us to establish a knowledge base, also the training of specialized human resources, and also the creation of Brazil's first dedicated research labs in hydrogen system. So this early work is important because it shows that Brazil's hydrogen agenda did not appear suddenly, but it was built gradually and with scientific continuity and public investments. So one milestone that I like to mention here is the early phase of the PROCAC program, focused on fuel cell technology development. So this program supported research and development projects in universities, enabled collaboration with energy industrial players, and also laid the foundation for Brazil's later transition towards broader hydrogen strategies. So from this base, the program eventually evolved into what we call this, the PROCAC eventually evolved to what we call the PRO-H2, which I will present this program shortly. So the lesson here is quite clear. So long-term research programs matter. So they create capabilities that allow countries to move from research to innovation to industry. So this also we have our Brazilian initiative, Brazilian Hydrogen Initiative, and also we have the CIS-H2, which is a system. It's a network of labs that we fostered. I will talk a little bit about it shortly. Regarding the national hydrogen program framework, more recently, Brazil advanced in establishing a policy and governance framework for hydrogen. So two milestones are central. First, the law, the 14948, which established the national guidelines for hydrogen, and also the resolution from CNPE, the number 6, 2022, creating the national hydrogen program. So under the PNH2, the Ministry of Science and Technology and Innovation leads the committee focused on technological development. So this committee ensures that innovation is not isolated, but it is embedded in the national strategy. So it focuses on these pillars here: scientific research, and technology development, research infrastructure, talent formation, support for startups and innovative enterprises, and also the coordination of collaborative R&D networks. So this thematic committee on technological capabilities, the MCTI coordinates these 5 core actions. So R&D and innovation programs, strengthening labs and testing infrastructure, also entrepreneurship and the technology-based startup support, collaborative national and international R&D networks, and studies and knowledge dissemination. So this structure is key to ensure that hydrogen innovation is not fragmented, but it creates some kind of alignment between research, industry, funding, and also policy. So to operationalize these priorities, the MCTA launched this is what we call the Brazilian initiative, Brazilian Hydrogen Initiative. So its priority technological domains include renewable hydrogen production, storage and transport, safety and certification, and also industrial applications in steel, fertilizers, chemicals, transport, and power. So the objective here is very clear. So Brazil must be not only a producer of hydrogen, but we need to act as a producer of hydrogen technology. So I think here it's important to emphasize that we have some evidence here of collaboration between Brazil and Finland. So especially in safety and certification, industrial digitalization, and also materials and process optimization. So regarding the funding, the National Fund for Scientific and Technological Development, our main source for funding research and development projects, we have financed 23 research and development projects focused on sustainable hydrogen and production routes. So the investment here is 15.8 million reais, and these projects strengthen domestic scientific production and also feed innovation pipelines that later support industrial scale-up. So the thematic line 3 here, which is hydrogen for transportation. The transportation sector is another strategic field for Brazil. So through this line, the thematic line 3, 2 major projects were funded with the same source, totaling 14.9 million, focused on hydrogen mobility solutions and also logistics, and also refueling stations and supply chain integration. So this aligns with Finland's strong experience in mobility, digital systems, and safety standards. So another point of synergy between Brazil and Finland. Another topic here, in 2023, Brazil expanded to low carbon industrial hydrogen applications. So 7 major projects, R&D projects, were funded, 55 million reais from FINEP, which is our funding agency linked to the Ministry of Science and Technology, and also with 25 million in private academic counterpart funding. So these projects are already forming the pilot scale and pre-industrial demonstration environments. So where here the cooperation with Finland could also be rapidly integrated. And I like to mention here about our SIS-HU, our system, which is a network of labs that we supported in order to advance in research and development projects linked to the industry. So in order to ensure scientific industrial autonomy, we have created this network with the first 16 labs at total. The first call 12 labs, and the second call we will integrate 4 more. 41 million it was invested in infrastructure and equipment. So this network here enables electrolyzer and materials testing, standardization and certification procedures, and applied research linked to the industrial demand. So this is a very important research initiative under the ministry's scope. So it's an ideal platform for Brazil and Finland to collaborate. It's very easy for us in the ministry to bridge these connections with these labs. So I think this is a great opportunity to strengthen our collaboration. So I think Brazil and Finland, my final remark here, Brazil and Finland, we share the same strengths. So by linking our renewable energy matrix and also our industrial scale with Finland's excellence in industrial process, efficiency, safety, and advanced engineering. So I think we can build technological solutions here with joint projects and not just trade opportunities. So I look forward here to deepening this cooperation and developing also a shared hydrogen innovation ecosystem. So thank you so much, and sorry again because of the delay, but I'm happy to discuss this collaboration if you think this makes sense, or establish this connection between Brazil and Finland. Thank you so much.
Thank you once again, Osório, for your patience, for being with us being here with us until now. Thank you very much for your thorough perspective on Brazil's clean hydrogen overview and policies. So yeah, we are past our finishing time. So, and I don't think we have any questions for now. So I would like to emphasize once more that if anyone who has registered for the webinar would like to pose questions to the participants, they can send the questions to this email, like sectec.helsinki@itamaratu.gov.br. And we will be happy to forward the questions to the participants who have kindly agreed to answer them for you. So yes, our time is up. I'd like to thank most warmly to all the participants who joined us. Okay, we do have a question. So let's just this one. Let's just have some minutes here for this one. So Gabriela Madeira. Mr. Coelho, in your view, what strategic actions could enable Brazil to move beyond being solely a producer and exporter of renewable hydrogen and instead retain and apply this technology domestically to foster national innovation and industrial competitiveness?
Yeah, this is a great question because this is exactly what we are trying to foster in Brazil, because we have to escape from this commodity trap, investing not only in the upstream process, but especially in the midstream and the downstream processes. This means that we need to foster research and development projects that are linked to the industry. So we need to be aware of what the industry is demanding from the academia. And we need to be, as the government, we need to foster by establishing and developing and implementing policies that are effective in order to support the midstream and downstream processes. So once again, this national network of labs, it is our, let's say, one of the main projects that we have in order to support the demands from the industry. And also one other thing that I didn't have mentioned here is that recently, specifically 2 weeks ago, we have launched our competence center for hydrogen in Brazil. The ministry through Embrapi, which is is a social organization linked to the ministry, we have launched a public call for institutions that are willing to be this competence center in hydrogen. So this is another initiative that will be very important to connect academia, capacity building, and also demand from the industry. So this is, let's say, a set of policies and initiatives that are looking and are seeking to address these demands from the industry. And again, I don't think we will advance if we not, let's say, emphasize and support projects, especially in the midstream and the downstream processes in hydrogen. Thank you.
Okay. Thank you, Osório. Thank you, Gabriela, for your question. So yes, now I'd like to thank everyone once again, those who spoke here to us today, those who registered for the webinar. Hopefully you're able to get quite good insights on new collaboration opportunities between Brazil and Finland. And before we finish, I'd just like to remind you once again that this has been the first of a series of webinars focusing on low carbon hydrogen initiatives in Brazil and in Finland. So next year we will have a webinar focusing on clean hydrogen use at ports in those two countries. So you will hear more about it in the future. So for now, I wish you a great week and we hope to see you on our next webinar. Bye-bye. Have a great week.